Hello, everyone. This is Ryan Seaburg from Qubit Networks coming to you live from our worldwide headquarters here in lovely LaPorte, Indiana. And today I'm here with the great Ron Trepton. Ron is, we were talking about it before we started this, that I believe he is the very first network security engineer that we had. So Ron's been with us a long time. Consider Ron to be a good friend and great worker. So today we're going to talk about wireless. And Ron, how long have you been kind of in the wireless game, would you say?
Oh, I would say, I've been doing wireless probably since 2000, 2007-ish, roughly thereabouts.
So quite a while. So you've seen a lot of changes in the wireless game, and
Right.
I know that together, and I know separately, you've chased a lot of wireless gremlins.
That's that's an understatement.
In your time, right? And so I like to say that we kind of got some gremlin catchers now in some of the tools we have.
Right.
But running down some of these wireless problems in the early days was quite a trick.
Absolutely.
Yep. So what we're going to want to talk about today, though, is the difference between 2.4 gigahertz and 5 gigahertz wireless. Today I would say out in the wild, so to speak, there's a lot of both.
Right.
Most wireless access points now do both, right? They have 2.4 gigahertz radios and 5 gigahertz radios, and why don't you just give your opinion of both of those and some of the challenges we've seen, kind of with those.
Right. So Wi-Fi has always been kind of like the catch-22 in networking, meaning that on one hand, 5 gigahertz, you've got all these additional channels, and you've got less chances for those channels to interfere with other Wi-Fi, whether it's your own or whether it's other customers that are other people that are nearby. Also, less interference from, say, like microwave ovens. But on the flip side, 5 gigahertz, of course, as we all know, doesn't reach out and touch someone quite like 2.4 gigahertz. 2.4 gigahertz, unfortunately, with only 3 non-overlapping channels that you can use, has from what we've seen, I'm sure from what you've seen, causes interference overlapping with your other access points, with access points nearby. A lot of other items, devices out there use 2.4 gigahertz, whether, like I said, microwave ovens, whether it's, we see like a lot of video cameras nowadays. We've seen cordless phones. A lot of cordless phones use 2.4, a lot of older cordless phones.
Yeah, I remember those spread spectrum phones were notorious for killing Wi-Fi because it would just run the whole spectrum.
Right, frequency hopping devices.
Right.
Absolutely.
Yeah, funny story on that microwave oven. So one of our customers is a large manufacturer, and they were doing some training in a room that was right next to the break room, and they were implementing this whole new ERP system, and there was a lot of eyes on it, and it was actually a Japanese company. And I got an email forwarded to me, and the title and the subject line was in Japanese, and our contact there said, when you get an email and the subject line is in Japanese, it's usually bad. And so the Wi-Fi was going down, and they couldn't conduct this training, and so we had to scuttle to get out there, lickety split, and we found out that there was about 10 microwave ovens on the other side of the wall from the conference room. And every time there was a break, guys would come in and grab these like little burritos and things, and they'd fire up all these ovens at the same time, and it would just kill the Wi-Fi.
Right.
And that was the fix. Was like, okay, we have to get on the 5 gigahertz, right?
Right. Yeah, and of course, as you were saying, all the customer client devices were using 2.4 gigahertz. So yes, that was the fix, is to move everybody to 5 gigahertz, and that's what we see with a lot of customers that have dense deployment of access points. It just makes that 2.4 gigahertz, the use of 2.4 gigahertz, even worse. So anytime you're inside, you have a dense deployment of access points, or say you're in an office space where there's a lot of other customers that bring their own wireless access points in, we see just tons of problem with 2.4 gigahertz. So that's why the recommendation is to always use 5 gigahertz, have enough access points to cover the area because again, the 5 gigahertz does not reach out like the 2.4 gigahertz. I will say there is times where 2.4 gigahertz actually
absolutely
does make sense. And what we've seen is outdoor deployments in a I'd say not exactly a rural setting. I mean, rural setting is great, but even in a
Yeah, not a high Wi-Fi area, so maybe not downtown Chicago,
Exactly.
but if you're in,
Mhm.
if you're in downtown LaPorte, it's probably okay,
Sure.
right? So,
Right.
yeah.
Yes.
So some point-to-point connections between, buildings or even just, outdoor Wi-Fi in general.
Mhm.
We've also seen it in, work well in like a warehousing setting if you're, kind of shooting down an aisle.
Right.
Because you can go a lot further with the 2.4 gig, and it's kind of contained, and you can get the antenna to concentrate that down a certain spot. Or we have some transportation customers that have tunnels.
Right. Yes.
So in those
Mhm.
types of settings, it's good as well. But yeah, so just we've learned some lessons over the years,
Sure.
and
Yes.
that's one of the things I think. Just kind of in general, we like to design a facility like when we're asked to design for Wi-Fi, we design it for five gigahertz.
Yes, we always design for 5 gigahertz.
and then have the 2.4 kind of in our hip pocket
Mhm.
when and if it's needed. So,
Right.
Ron, always a pleasure to talk to you about a variety of topics, whether it's a Wi-Fi or the Bears or the current virus we're having, right? Whatever it is, it's always fun. So I appreciate everything you do for us, and thanks everybody for watching.
Thank you.